Hello students, welcome back. Yes, up till now we have seen two methods for determination of particle size. Now we'll see the remaining two methods to determine the particle size. So the third method for determination of particle size is the sedimentation method. Now this method can be used to determine the particle size in the range of 1 micrometer to 200 micrometer. As we know, different methods are or different methods can be used in different range in order to determine the particle size. This method also gives the weight distribution like sieving method. The diameter which is obtained by the sedimentation method, that is known as a Stokes diameter, which can be defined as the diameter of the sphere having the same sedimentation rate as that of the asymmetric particle. The meaning is that the spherical particle and the asymmetric particles both will have the same sedimentation rate. So that is known as the Stokes diameter. Now, why the name is given Stokes diameter? Because sedimentation method based on the principle of the Stokes law, the basic principle underlying this method, that is the sedimentation method, is the Stokes law. That's why the diameter which is obtained, that is known as the Stokes diameter. We can see the equation in the presentation. The equation is given, that is the Stokes law or the Stokes equation. We have seen several times in the suspension or the emulsion. We know that that is applicable for the sedimentation, which is known as a Stokes equation. The second equation which is shown in the slide is a modified form which is rearranged in terms of the Stokes diameter, so that we can find out the Stokes diameter by finding the various terms. As we know, the various terms which are present in the equation, like eta indicate the viscosity of the dispersion medium, h indicates the height, g indicate the acceleration due to gravity, t indicate the time, and rho s and rho 0 indicate the densities of the particles and density of the dispersion medium respectively. So these are the various terms which are present in the equation. Everyone is aware of those terms. In order to apply the Stokes law, there are some conditions to apply the Stokes law. The first condition is that whenever sedimentation occurs, the sedimentation of the particles should be free in nature, without any hindrance or without any disturbance. Particles should not interfere with each other. Hindrance means there should not be any interference of the particles during the sedimentation with each other. Okay, so free settling should be there. That is the first condition for the Stokes law to be applicable. Apart from that, if the particles aggregate or particle clumps together, there is a formation of the aggregate or clumping of the particle, then the Stokes law is not applicable. Now, why such condition is there? Because whenever particles aggregate or clumped, at that time sedimentation rate increases. So that's why the Stokes law is not applicable in this condition. Next condition for the Stokes law to be applicable is the flow should be laminar. The flow of the dispersion medium around the particle, it should be laminar in nature. It should be streamlined in nature. If the flow is turbulent, the Stokes law is not applicable. Now, how we can distinguish or differentiate between the laminar flow and the turbulent flow? Actually, it depends on the Reynolds number. Many times you might have come across this term, that is a Reynolds number. So if the Reynolds number value is greater than 0.2, that indicates the turbulent flow. If the Reynolds number value is less than 0.2, that indicate the streamline flow or the laminar flow. So that is a third requirement for the Stokes law to be applicable. So these are the various requirement or the conditions for the Stokes law to be applicable. Now Reynolds number equation is given here. Reynolds number equation and Stokes law equation, these are compared, and finally we get the modified equation that is shown in the slide. d cube is equal to, now in order to determine the particle size by sedimentation method or on the basis of the sedimentation method, we have the several instrument like pipette method or the hydrometer or the balance method. But out of these three instrument or the apparatus or the methods, we use the Andreasen apparatus. Now, as far as the Andreasen apparatus is considered, that is shown in the figure, you can see the Andreasen apparatus. It consists of a glass vessel which is having the capacity of 550 ml, and one pipette is inserted or introduced into the glass vessel, that is a 10 ml pipette. So you can see in the diagram also, one glass vessel is present having the capacity of 550 ml, and one 10 ml pipette is present. So you can observe in the diagram or the figure. Now, when the pipette is placed in the cylinder, that should be at least lower end of the pipette, that should be 20 centimeter below the surface of the suspension. You can see in the diagram, the 20 centimeter mark is present, and the lower end of the pipette is below 20 centimeter in the suspension. So that is one of the requirement. Now, what should be the concentration of the suspension that should be prepared in order to determine the particle size by using the sedimentation method? As we know, one more condition for the Stokes law to be applicable is the suspension should be dilute in nature, so that there should be minimum particle that can be easily counted, or that the particle size can be easily determined. Or for free settling also, the concentration should be less, because if the concentration increases, number of particles increases. If the number of particles increases, then that will lead to the hindrance, or the free settling will not occur. So suspension should be dilute in nature. The first step involves the preparation of the suspension, that is 1% or 2%, that is a 1 gram in 100 ml or the 2 gram in 100 ml is sufficient to prepare the suspension. When we prepare the suspension, at that time, don't forget to add the deflocculating agent in the suspension. Now, what is the function of the deflocculating agent? Deflocculating agent is added in order to disperse the particles, in order to distribute the particles uniformly throughout the suspension, so that free settling of the particles will occur. So deflocculating agent should be added in the vessel or in the suspension. Now, once the deflocculating agent is added, the suspension is transferred into the vessel, 550 ml vessel, and the whole assembly, then insert the pipette into the vessel, and the whole assembly is transferred into the water bath in order to maintain the temperature during the experiment, in order to maintain the temperature constant during the experiment. Okay. So whole assembly is transferred into the water bath. Now, after a definite time interval, once the suspension is added and the whole assembly is transferred into the water bath, shake the suspension or shake the vessel before starting the experiment, so that there will be uniform distribution of the particles in the suspension. Now, start the experiment at every or after a definite time interval, that may be 10 minutes or 20 minutes or whatever. So at a definite time interval, withdraw or take 10 ml of the sample and transfer into the watch glass. So conduct the experiment for the definite period of time, and the samples which have been collected at different time intervals, evaporate the samples, and finally take off the each sample, take the weight of the sample, each sample which is collected. In this way, we'll get the weight of the particles. Then we can calculate the percentage weight, we can calculate the percentage frequency, then plot the frequency distribution curve, plot the cumulative frequency distribution curve, and finally determine the Stokes diameters. So that is all about the sedimentation method for determination of the particle size.